Welcome to Amberskies. My name's Blades, it's Saturday, and we're going to learn some programming. Yeah, the old-fashioned way. Oh yeah, we've got tests to write. We've got a Mat 4, a Matrix 4 to write, and hidden in the background, I've also set up the Quaternion. Oh, scary. No, not really. It's just maths. Right, so what do we need for a matrix? Welcome to the matrix, huh? We want little things to drip down our screen and make funny symbols. No, we don't. We want to live inside the machine. Oh, that'd be nice. No, we don't. Nope. We want to program the matrix. So, my name's Blades, and today we're going to go through the matrix. How shall we do that? Well, interesting. How shall we do that? Oh, so many different ways. And this is something called Java, isn't it? Yeah, I'm programming in Java today. That's good news. I think I know what I'm doing now. So, it always starts with a word like something like that, doesn't it? Then we have some kind of thing like that. And I don't know. So, we'll call it M for matrix. That's original. Okay. So we've got that far, and we are going to test the constructor. Interesting. What shall we put for a constructor? How's about public Mat 4, because I think we like Mat. Yeah, Mat 4. I'm trying to think of how GLSL does it, not how we're supposed to do it in Java. So Mat 4, it just makes things less confusing later on when we do the GLSL. Right, we have a constructor. So let's try and construct. So, Mat 4 matrix or victim semicolon. That seemed to work. No silly lines yet. So these are floats, and I haven't done my floaty bit. Okay. And we discovered that floats weren't reliable, didn't we? So we should have a floaty bit here in test for the vec3. Yeah, we have. We've got float equals. Right, I want to include that then. So that can go into here. What else do we want from vec3 test? Oh wait, I'm not going to put it into quaternions as well, can't we? Yeah. We might just need it, so I'm going to pop it in there as well. And I had a warning, didn't I? So we shall put our warnings in, so that we're not misleading anybody. There we go, that'll do. That'll do nicely. Control S for a save. I think that works. So let's get back to here. Alright, so I've got a bit more that we can work with. Should have kept that open actually. this side though. We're doing assert true, float equals. Okay. Let me just get this off the constructor here. So this is the kind of test that we're doing for constructors. Alright, that's fine. At least now I know roughly what I'm doing. We need getters and setters, don't we? Mat4 won't do it. Okay, have I got getters and setters in here? Something just happened. Okay. Why have you just come over here? Didn't want you over here. This is going mental. What's going on? So I'm doing map 4. Testing. Right, thank you. Let's see. Set. Get. No. It's not going to do those. We're going to have to write those. Okay. That's wrong. Good start. I haven't even started and I've already written something that's wrong. That's an interesting idea. Let's have a bit of space and see what we can do. Right, assert true, float equals. 1, and we need to get. Oh, that's difficult, because we can't. Right. Okay, so let's do getters and setters then. Okay. That makes this easier. Get rid of that line a second. That's no good to me. What have we got? We have the following. Alright. How are we going to actually do these, do you think? These aren't as straightforward as normal ones, so we're going to have to be slightly more careful. And it should be alright, I think, if we do it carefully enough. Alright, let's try and do the first one, get matrix. So what we'll have is a public, so they can access it. It will be a float, blah blah, and we're going to call it get matrix. I'm going to call it get mat4. Yeah, why not? Call it anything I want. That'll do me. Alright. And it doesn't do anything, so it's got to return something, hasn't it? Return a new mat4. Can we do that? No. Okay. I can't just do it that way either. Alrighty, this is already becoming a problem, isn't it? So I'm going to need a mat4 temp equals a new mat4 semicolon, and then we can just return temp. obviously we can't. Alright, it had to work itself out, I suppose. I haven't put a mat 4 over here, have I? I did there. Okay, never mind. So, that's the first one we want to do. So, let's do this one here. What kind of testing can we do? We will need a matrix. So, we'll do the same as we did over there, which is mat for victim equals a new mat 4. Okay. We can't set anything at this point because we haven't done the setter. So what we will expect is zeros. This could be a bad test. Right, so it should return what are we returning with this? A float and 2 numbers, not a vec2. Okay. No, I don't want that. That's not the test, is it? So it's going to be float victim equals... There's going to be no way of testing this, is there? I'm struggling. Anybody got any ideas? Okay. Let's have a look. Mat for prime equals a new mat for... These are not going well already. Semicolon. Equals prime. Don't understand it. Prime. Whoops. What's happened to caps lock? Get rid of that. Prime. Dot. Get mat 4. No. I don't normally do the getters and the setters. Because they're machine generated, aren't they? I don't seem to have a standard for them. Did I do them in test 2? I might have done by accident. No, because it affects all the other tests. Okay, I can't actually think of a way of testing it. That's interesting. Anybody can think of a way of testing a mat4? Get mat4. I know what it does. It gets a whole of a mat4, doesn't it? It's like a copy. So we can copy like a matrix to a matrix. Ah, well maybe there's the answer. We can copy a matrix to a matrix. So take that away from there. Because I don't think we can put victim equals prime or prime equals victim. That's what I was thinking. Victim. Let's put it as a mat4. Alright. Am I allowed to put that without the get? If I am, I don't know why I'm doing a get method. Right. That makes no sense to me whatsoever. Okay. So, what do we expect? So, prime is the giver of the result, and victim is the receiver of the result. We are looking possibly at something like that. That's going to be awkward. That's going to be a little bit awkward. Let's just paste it in and see what I can do with it. So assert true, float equals, and I can't do it without that one. And I need that one there, get the XY, don't I? To complete this one. Oh my god. This is a chain event. So I need the next one down to be able to do this one. Oh my god. Okay, so what would that one be? That's get XY. So they'd have to be equal on the get XYs. Okay. Which is public float that's right, it's a float that we are going to receive, and what we're going to do is we're going to just get, and it's going to be int row and column. So that's what we want for the float. We want to take one float out of a matrix of 4 by 4. I'm just going to have to do that one now. Paste. Alright, it's a float, isn't it? That satisfies the building techniques. Can we build now? Oh no, we've got an error here. Damn it. Getting into the swing of this one's going to be difficult. It's the same, isn't it? Sort of. Alright, so no. Don't need you. We just need a float, don't we? Float result. Result equals victim dot get. I'm going to choose 2, 2. Okay, semicolon. We would now expect 1.0f to be the same as the float, which is result. My God, I think I've got something right. Right, our victim's not working. Good, that's alright. Victim, will you please do some work for us? I don't need that line. Alrighty, I think we've got something. So that's your variables, that's your action, that's your assertion, that's a test. Is that correct? Well, obviously no, it isn't. Oh, I expected a what? Error 2231 in Mat4 Java. Float temp equals new float. Return temp. Huh? Expected square bracket. Okay. What? What is he talking about? Okay. Can we try this again, please? In the test, 5544. Here. That's easy enough, I can do that one. And you can do that and try again. Yes! Finally, we get something that worked. The problem is it's not going to even work when I put the right thing in, is it? Probably. Right, okay. Okay, let's put the correct answer in, shall we? For a get on a matrix 4, it's going to be return m x, sorry, row and column. Right, that's the answer. Well, it's the answer I think it is. And we've got dotted lines now here, And of course it can't be true. We'll run. Data's wrong. Because we can't set it to 1. We've got the get. We need the set. We need that one there. So these work in tandem. You can't do tests for these, can you? Really? I'm going to do no tests then. I don't really want to do this the hard way. So all the getters and setters, I haven't been testing them anyway, so I'm not really bothered about these. Because all they do is return straight, not doing anything silly, except for one of them, which I think we should test. Alright, we'll get rid of this. Good start. I've written code and I'm getting rid of it. It's always a good start to the day, that. You can always tell when I'm starting. Getters and setters. No test. Right, let's write the getters and setters then. What do we want for this one here? Get map4. That's return M. No, it's not. No, it's far from it. Can't do it like that. It's not going to work. So, float. Get M. Oh, on that bit. Float. Result. Equals a new float. And we're doing a 4x4 matrix, aren't we? Yeah. That. Right, that's a 4x4 matrix. And okay, 4 int. Helps you put the bracket up first. Int I equals 0. Whilst I is less than 4, I guess. And we'll just increase I. Next line will be 4j. Yeah, we'll use j. Int j equals 0. J less than 4. I'm just going to set everything to 0. Which is why I knew it wasn't going to work. And it's j++. So j is less than 4 as well. Okay, that's good. Then all we need to do is put res or result I j alright, it's a copy here. So we're copying them over M I j. So that's a full copy from one to the other, creating a new map4 and sending that out as a result. Yes, we have a result, literally. Why can't I go backwards? Why can't I go to the left here? Huh? Return result. It's not liking that, is it? Alright. Alright, yeah. Get map 4 is float. Okay, that should do it. Will that work? Yes. Good. Getting row column should be a lot easier. Let's return M row column. Yeah, okay. Is that all we need? Do some setters as well. Let's do it here. So what we got for the first setter? We have a public void. What should we set? Set M. And that will have to take in a float M. Sounds okay to me. So this dot M equals M. Done. Next. And now we want to set an individual value. So it's public void set, and it's going to be int row int column and float value. That's not too bad, so we'll pop that one in. Give ourselves some more room to work with so you can see what's going on better. And all we have to do here is M row column equals value. And that's it. That's your getters and setters. They're just not straightforward. If you try and get them automatically created, it ain't going to create this, I don't think. So I didn't use auto on that. But that would do it. I'm going to pull you lot off. Totally. Just delete you. So that I know that I haven't got them, because they're not there. Right, well now we can try and do some of these ones here now. So, constructor. Assert true, float equals. Zero. And it's going to be victim get M, isn't it? Or get map 4. Alright. Let's do it properly. That's the constructor. So what we want to measure is the victim dot that one. And we can't. Wrong second argument type found. Float float required double. What? Why do you require a double? Isn't this supposed to be an array? Have I done something completely stupid? I think I have, you know. You're not allowed to put values in. Okay. I know. Is it because there isn't a constructor here? Is this what's going on? Wrong second argument type found. Float float required. Double. I've not met this kind of thing before. Make get map 4 return double. No. More actions. Change second parameter of method float equals from double to float float. Okay. Good point. I hadn't thought of that. So this isn't going to work properly now. Why? Oh yes, it can't, can it? I'm trying to put that in. Okay. Yeah, okay. So that doesn't work like that, but it will work without that bracket. I'm guessing. It's not going to work like that. Okay. We'll try 2, 2. Oh, blast. Numlock wasn't on. 2. Ha-ba-da-ba-da. And it's 2. That returns a float. Can't resolve method, assert true, float, float. Expected 0, victim, get row 2, column 2. So what I'm testing here in the constructor is, has row 2, column 2 got a 0 in it? Good question. Shall we find out? Good. No, it hasn't. Null pointer exception. Thank you. That's even better. So it's actually told us what the problem is, which is even better. So, learning to program. This is what the kind of thing that you're looking for when you're testing. The first thing you want to do is obviously generate. I've been over this every week, haven't I, really? But when you're testing, you first want to get a negative response of some kind. In this case, we've got a nice one. Because that tells us what we have to do to fix it. Most of the time you'll just have it say, oh, well, it doesn't quite work, but you need that false, because then we can now write the constructor, because most people wouldn't even think to, because it's a map 4, we have to, and that's a very good point. It is a null pointer exception. I didn't even realise it would give that back. That's awesome. Well done Java. I'm really impressed by IntelliJ IDEA. I really am. So, how shall we construct it? Alright, we'll do a simple constructor and see if we can get it to work. So, M equals a new float. I don't know if it's spaces or not. How does that look? Will that work? Oh, right, let's try that then. Straight off. There you go. That's all it needed. It needed a proper instantiation of M, because if you remember, I couldn't put the 4 up there, because all that does there is reserve memory for M, or tell the compiler or whatever it is, the translator on this, I guess, that this is coming up. Now we actually define what it is and construct it. So we've got a constructor. Thank God for that. We've got past the first step. Now we need to test the identity matrix. Now, do you know what an identity matrix is? Probably not. So I have a little explanation to do, haven't I? Have I got a blank area of screen here? Not really. Right. Have I got a mischief running around? No, I haven't. Okay. There's a mischief. I can get you from here. There you go. Skip that. Wow, that's bright. I need you back up. Yeah, we're okay. Oh, lovely. Alright, let's have a look at this then. Identity matrix, what is it? So, blue, splodge. Yeah, that looks like it. So, I'll just call it the ID matrix. What is it? It is the matrix which equals 1 in mathematics on multiplication and division. Equals 1 when used for multiplication and division. And that's important, because if you divide by 1, it cancels out of an equation. And if you times by 1, it cancels out of an equation. So if you do any equations with matrices in, and you have an identity matrix in there, it cancels itself out, really. That coffee was nice when it was warmer. So that's what an identity matrix is. And what it is in reality is 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0. Okay. So those are your rows. So that's the identity matrix. It's just got 1s going down the middle. So that times... So that equals 1 when you times it by another matrix, or divide another matrix by that, and it will do nothing. In other words, it's not needed. But it's also the starting point for how we do a 3-dimensional movement when we want to move a 3-dimensional model. So 0, 0, 0 here is your x, y, z. The 1, 1, 1 there is your scale, and these zeros here represent rotation. So this matrix holds all the information of where a model is, which way it's facing, and how big it is, its scale, whether it's bigger or smaller. So matrices are used for OpenGL. doing anything you want in 3D. And as we're doing a 3D game engine, I thought I'd better just introduce them to you. If you want to consider them as a little black box that does nothing, just remember that the identity matrix is very important. You'll see me set everything to the ID matrix at the beginning of a calculation, so that I know that A equals 1. So it's like saying int x equals 1. So int x equals 1 is equivalent to saying matrix or mat for dot ID matrix. Or that's what I'm hoping anyway. Something like that. That's the theory. Which is why I chose 1 on my first test. Because it's 1, 1, 1, 1, 1, 1, 1. Interesting thing is, it's how do we do that? And the obvious answer is manually. So, how do we check for an identity matrix? We need same kind of things we've got here. Alright, so we'll take those two. And we'll copy them. Paste. But this time, I do really want to assert true that the that the expected result is 0. That's correct because we've just assigned it. This time we want a 1 there. So assert equals a 1, and what we have to do that is victim equals victim dot identity mate. We haven't got one. Let's make one quickly before I run out of things to write. Public. It returns a map 4, and we'll call it init identity. Init capital O, no. That's better. Init identity, yeah. And it will have to return a new mat4. I think this should start working now. Yeah, it does. Now we've got the constructor in properly. Things are starting to work. That's nice. So that's the idea. So this is now init identity semicolon. So the victim should now have a 1 at 2, 2, as I showed on mischief. So 0, 1, 2. Oh no, 0, 1, 2. 0, 1, 2. Yeah, that one there. So that is the one that I'm pointing to there. That's 2, 2. Because we have to count from 0. So that's 0, 1, 2, 3. 0, 1, 2, 3. So it's that one there that we're after. Okay, that helps you out. I hope it does. That's row, and that's column. So there we go. That's the picture diagram. And I'm certain that that should now be a correct assumption to make. So let's test it. There we go. Assertion failed error. Expected 1. It didn't tell me what we got. Oh, there we go. That's better. Oh, there seems to be more stuff down here. That's my fault for not having a bigger window, isn't it? process finish, exit code -1. Okay, we're going to have a bigger window. That's alright, I don't mind. So yeah, expected 1, actual 0, which is correct for what we've done, and that fails the assertion. So now we have to set our mat4 to the identity matrix to make this work. And this is the fun bit. Here we go. And it's going to be M 0 0. Remember, we start at 0, and that equals 1. Is this floats? It is floats, isn't it? I don't understand you, Java. You'll let me do that, won't you? But it isn't. It's a 0 float. I don't understand. You can be lazy in Java, it seems, and just put a 1 if you want to. Yeah, right. M, and this is the rows, isn't it? Oh god, we've got to get... No, it doesn't matter. I'm not that bothered. 0. I'll work it out when I get there. 1. This is how my mind works. Is that right? Yeah. We need another one now. Then we'll go for 0, 2. As long as I'm consistent with this, we'll be fine. All you have to do with this is do it one way up and make sure that you're consistent. So you're either row major or column major. In this case, we look to be column major, I think. I usually write row major, but I don't do it this way anyway, usually. This is the correct way. Alright, okay. 0. Yeah, this is the easiest way to do it and the most efficient. Stupid, but true. Okay, that'll do. So what we do is we manually put 1 in that first slot. There. And now all we need to do is fill in the rest. So copy that. Two, 4. There we go. Yeah, I'll do the values first. Yeah, this is how we do it, folks. Fantastic, huh? Very complicated mathematical procedure. I'm doing it like this so that it looks the same as the diagram I drew. There we go. So that becomes a 1, a 2, and a 3. So those are your rows. So that's row major. Okay. A 1, a 2, and a 3. A 1, a 2, and a 3. I think you can guess what's going in this last lot here. A 1, a 2, and a 3. I think I spoilt that game. And all we have to do now is return this. There you go, and that will work. Let's close this a minute so we can see it now. It's a bit close to the edge, but hey ho, it just about fits in. It's probably the longest bits that I do are these mat4s. I'm just hoping that the other stuff on Quaternions will fit on a screen. We don't know yet, but we'll soon find out. Shall we test? Do you think now that row 2, column 2 will be a 1? Well, it says it will. Let's run it. And it does. Test correct. Fantastic. 2 out of 2. Not doing bad. Oh, we've only got one more to do. Okay. This is for the multiplier. That's a matrix times a matrix. Oh dear. How am I going to put this across? Because I can't use any of the fajangled. It's actually the dot product of the row versus the column, but that's not the way you should look at it. Right. If you need to multiply two matrices together, you take each of the rows and multiply them by the next one's column. That row versus that column. That row versus that column. That row versus that column. And that's how you multiply two matrices together. That's the simplest way I can put it. Go to Khan Academy. They have fantastic things on matrices. I think it is literally khanacademy.com, but check it out on Google. Look for Khan Academy, and they have fantastic. If you're really into maths and you want to know how it's all done, then please go visit them. They are maths. They have brilliant maths teachers. Helped me a lot. Helped me in the understanding of all of this an awful lot. And I went into the all the way through 4D, and fantastic. Loved it. Loved it every minute of it. Real and unreal numbers. So yeah, is it worth doing? Yeah. Mind you, I'm biased. So we're going to need a public mat4. We're going to generate a new mat4, aren't we? And we are going to multiply. And I'm going to do this in my normal way, which is going to be a mat4 right. And of course, we are going to return a new mat4. Okay. So over here, we're going to need prime and victim, aren't we? Yeah. So mat4 prime. Equals a new mat4. I'm not sure how I'm going to do this test. Mat for victim equals a new mat4. Well, what we want to do at the end of the day is, well, the action we are going to do is victim equals victim prime dot mul. Yeah, that's right. That's the command. And it's got a multiplication in it now, so I've got to be careful. Now I do want floaty fuzziness. We need an assert true. Okay. Yeah, we can't do an assert equals because we're actually taking a multiplicate. We can do equals here because we're not really messing about with the figures. Now we need to mess around with the figures a little touch. So I want to assert true. And now we're going to need this silly thing, aren't we? Float equals. Float equals. And that will be a value, a, comma, victim. I'll use the other one. Yeah, we'll stay with victim 2 or something like that. Actually, I'll change it. Copy. And paste. I think I might change that to... No, I can do that, can't I? It's going to be an awkward one. What shall we have as a result? Let's have 10.0f. Nope, just 10.0. It's a double. That's correct. Can you put an F in there? I think you can. Fits in, doesn't it? I mean, this is Java. It doesn't really bother as much. Got the right number? Yeah, I've got the right number of thingies. Now we have to mess around with these so that we can get row 2, column 2 to the correct value. Easiest way I can think of doing that is prime equals prime dot init identity. Can you do prime equals init identity? Can you do that? No. No. Okay. I'll think about that later. Okay, so we'll have identity for you. And for victim, equals no, it isn't. It's victim dot set 2, 2, 10.0f. So this is a validation of what we're saying about an identity matrix doing nothing, at the same time as just testing out that our set works properly. We haven't had a set m either. M equals this m. Not really too bothered. I mean, I could set identity through the set thingy, couldn't I? So we could do that at the same time, just to cover something else as well that I'm a bit worried about. So victim it would be dot set m. I don't like that. I prefer the matrix word being in there. prime. It's another way of saying equals to, isn't it? Prime doesn't fit the what? Okay. I will not do that one then. Alright, so those are the values. We have a multiplication because that's what we're testing, and we have an answer. It's not a very good test, but it should fail, or hopefully not. Are we failing? Yes, we want to fail. Right, okay. There we go. It was expected true, but we got false. So that does not equal. Yeah, I quite expected that. That's quite fine. Because it takes more than a return value to do this one. Okay, how's it done? Right, we're going to need a result, because that's what we're going to be returning. So result equals and that's going to be a new map 4. God, I've got to get it all. I'm starting to get used to this language a little bit more now, I think. I'm not overly happy with it still, but hey-ho. It does hide a little bit too much at times, I think. Alright, here we go. 4. Yeah. Those two. Why did it move everything around when I did that? Oh, right, it's done that, has it? Why does it do that? Strange. Done it again there. Right, okay. I want these so I can see the lines going between them. Alright, so we've got our IJ for loops as we did for the getMat4 business, where we have to transfer it over properly. And for this one we have to multiply. So it is going to be a result. Yeah, this is going to be funny. Result dot set, and it's I comma j comma value. Oh god, here we go. So it's m I 0 times right dot get yeah, that's right. I think, yeah, but 0 comma is j, close brackets, then we have to add, oh god, so it's plus I love doing these, 1 times, this is getting easy now, right dot get, and it's going to be 1 comma j. Oh, it's going to do this silly thing where it keeps crawling up the screen, is it? Plus I2 times right is pretty, once you get it going, it's alright. 2 comma j. And then it's plus I3 times right dot get 3 comma j. Okay, I think that'll do it, except for that number 8 in the middle. I0, I1, 2, 3. I0, 1, yeah, row 0, 1, 2, 3, yeah, we're okay. I'll do it. Alrighty. Is that correct? There's only one way to find out. We've got a red mark. Let's turn it green. We turned it green. That is correct. Wow. And if you don't believe me, you'd have to do further tests. So I would let you work those out yourself. And I think you should. You should not just do these tests that I'm giving you. You should also do multiple tests, but each one should try and break what we've written. So if you can write a test that breaks that and still gives the right answer, then this is wrong. You know, that's how this game works. You write your test. If it fails, you correct your code. If it succeeds, you leave your code alone. So as soon as we've got a green arrow, we're off. We're gone. But if you can write a test which fails, so if you get a green arrow but you can still write another test which fails, then you have to write that test. If you know there is one, write it. So if there is one that you know of, just shout it out and I'll pop it in here and I'll rejig my thingy to make it go green. Let's just make sure that we're okay. Let's run our maths tests. Yeah, matrix, the constructor's good, multiplication's good, and initialize the identity matrix is also good. So those are the 3 that I think I want to start off with. Those are the main 3. We've got vectors, got vec3, haven't we? Yeah, so we're alright. Now we come to something lovely doubly. What's this? Well, that's a damn good question. What is a quaternion? How the hell am I going to answer that? Let's have a look. It's quarter, and then it's N-I-O-N. And we'll try for a wiki. Right. In mathematics, it's a number system that extends the complex numbers. Okay. And applied to mechanics in 3-dimensional space, a feature of quaternions is that multiplication of 2 quaternions is non-commutative. Wow. They've really used simple words here, haven't they? It's of 2 directed lines in a 3-dimensional space, or equivalent as the quotient of 2 vectors. Yeah, I suppose it is, but what does that mean? Right, a binary operation is commutative. If changing the order of the operands does not change the result, It is a fundamental property of many binary operations, and many mathematical proofs depend on it. So it is non-commutative, it's said, which means if you change the order, it changes the results. Operands does not change the results, so this is changing the results depending on which way round. Yeah. So x times y is not equal to y times x. Wow. That's unusual. So 1 times 10 does not equal 10 times 1. There you go. That's what that means. Quaternions have that feature or property. But they do have another property for us. They help us with 3D models in a 3D space. And by that I mean that in a quaternion there's 4 numbers. Alright, they're actually simple. They're not as bad as they sound. So it's just the wording that they use, and the features of these are fantastic. But a quarter I've forgotten how to spell it now. There we go. It's quat. It's a T. It equals an X, a Y, a Z, and a W. Come on, who's going to be the first one to say it? Hey, hold on a minute, that's a vector 4. No, it's not. That W matters. This is the only real number. This is fictional. So never get confused with a vector 4, which is comprised of 4 real numbers. A vector 4 with vec4 float is an x, y, z, w of 4 real numbers. A quaternion, the only real number is the w. And what we are going to do is something very special. As I clobber the cat, get off. What are you doing? The cat's pulling my speakers on the floor. Oh, I see. Right, okay. He's going to sleep now. And what we do to make our calculations easy is we make our real number equal to 1.0f. That's it. That's all we do. And if you know anything about the mathematics, it means a homogeneous coordinate. In other words, a single point in space. Then we can make all of this relative to that single point in space, which allows us to rotate around it, meaning that our x, y, z components can rotate in 3 dimensions, whilst our w stays at that point. It allows us to rotate in a 3-dimensional space. There we go. That's what it does. Let's have some. Let's have some quaternions, I think. I think that's a good idea already. So how do we set this up? Yeah. As you can see, I've already put constructor 1 there. Is more than one constructor to this. But we're only going to do one, I think. For now. So we've got a public class. And we are going to have a set of variables, a private float, x. Yeah, I'll do. A private float y, xy, I think you can see what's coming up here. Private float z and private. If you're not into the maths, don't worry about it. Doesn't matter. One slight little bit. Once you've done a maths library once, you can just copy and paste it to wherever you want. All you have to do is type it out once. How are we going to construct it? We'll need a public. And it's going to be a quaternion. There we go, that's our constructor. Alrighty. So it's the same test really as we used for the matrix. So it's these two lines again, really. We'll just have to modify it obviously to a single line, but let's try it out. So now what we want is okay, so quaternion victim equals a new God, I'm struggling on this spelling. Quaternion, right. Assert equals expect 0. You know what I haven't done, don't you? Which one is it? Is it insert? New in this directory. No, it's not that then. Alt return. Does nothing. Okay. How do I get that to work? Column selection mode refactor. Refactor? No. Generate. Getters and setters. We'll have the lot, please, Bob. Shift click. There we go. This will help us a lot. See, that's what we couldn't do with the mat full. And it's why I don't do tests for them, because I didn't write them. So we can expect that equals on victim dot, it's small, isn't it now? Get dot get, I'll just take the first one. That'll do it really. But really we should do that, that. Alright, we should have all of those. Right, let's check them all whilst we're at it. So, will our constructor work? I blooming hope not. I did. Damn you. Really? Alright. That's a shame, because that's not the constructor I want. Now you can see what I mean, there's going to be different constructors for this. So that one works. It's not the one I want, because I want to be able to set up the quaternion at construction time. So float x, comma, float y, float z, float w. Will that still work? Or will that fail? Excellent, it failed. Found no arguments. Reason actual and formal arguments list differs in length. Really? I've got float x, y, z, w, float x, y, z, w. Alright. So we can't, that breaks, which is good. Because now all we have to do is this dot x equals x. I hate doing it this way, but hey ho. This x, y equals y. This z equals z. And this x, y, z, w equals w. Okay. That's you done there, so that constructor no longer is valid. We would have to put 1.0 f, comma 2.0 f, comma 3.0 f, comma 4.0 f, comma and alter these to 1, 2, 3, 4. That's the correct test. We test. Illegal start of expression. Test Java on 26. What? You're right. And that might be better. Should we try that instead? Yeah, that's okay. Right, so if you can run a test by changing these numbers here and changing these numbers here, or doing another different test that can break that line with those equal signs, then that's fine. You'd have to rejig this constructor. I'm not sure there is one. I don't know if there is a test, but hey ho. Length. So we will take our... Oh my god, I've got to work out the length of this. Okay. Yeah. Copy. Thanks. I'm going to put all of these to 2. I can do probably 2. I hope I can anyway. There we go. Okay, so I've got a quaternion full of 2s. What do we want to do with it? We want to make a length. So it's going to be a public float. The length of a quaternion is a float. So that's a public float. And it's just going to be length. Do I need to put anything in there? No. Okay. And it returns a float. There you go. That now returns a float. Over here, float result equals victim dot length. And now we can assert true. And we can use our fuzzies, our epsilon. So that is float equals. Assert true. Float equals. And we're going to work out the result in a minute. A comma result. Because I don't know what it is yet. What's the result for 2? It's x times x. 2 2s are 4, so it's 4 plus 4 plus 4 plus 4, which is 4 4s are 16. That's the result. So let's do that and run. There we go. Expected true, but it was false. Fantastic. So let's see if we can do this. This is... No, it's not 16, is it? Sugar. It's Pythagoras, so it's a square root of. It's float mass square root. Okay, that's how you do it. So that would be float math dot square root, and we just have to put brackets around that bit. That's correct. That's the formula. So before I do anything else, just check that's still not got the right result. Always check. Even if it's obvious, check that you get that first. If you don't, there's something wrong. Seriously wrong. So here we go. We've got to do it here now. Right, okay. I'll try. I'll do my best. So it's float math dot square root of x times x plus y times y plus z times z. No comment. Oh, we have got a comment. What? Haheda. Oh, Heydam. Heydam. Is that? By the way, I believe it's quaternion and not quar. Oh, right. Big R. Right, I missed that. I don't know where I put it. Never mind. But thank you. Keep pointing it out. Believe me, I don't like making mistakes, but I do them. So you're quite right to shout out in the comments. Please continue to do so. There is no... I have no pride. And I give all my code away free once it's worked out. But I do love this system of doing tests and stuff. I mean, it's more relaxing actually programming this way. Because at the end of the day, true and false. Oh dear, it's not 16, is it? It's the square root of 16. That would help. And it's 4. Don't know why I'm putting that in. Have I got enough brackets here? Yeah. Okay, let's try that again. True. There. Expected true, but we got false. 4 4s are 16, aren't they? Alright. Let's have a look. I didn't want to do it this way because it's cheating. To me it is anyway. Equals. There we go. Get rid of one of them. Let's try it again. Actual 2. Square root of... what, 2 squared? Really? X times x, 2 times 2, is 4. Plus 4, which is 8. Plus 4, which is 12. Plus 4, which is 16. I'm not going mental here, am I? And square root of 16 is not 2. So, float math dot, have I found an error? Square root of 16 is equal to result. Why have I got a red line here? Oh right, it's the assertion failed error. Right, okay, fine. No, I'm right. It's 4. Why are we getting 2? Float result. Victim dot length. Where's that length going to? Go to implementations. Yeah, goes to the right one. There's a conundrum. Public float length gives me the wrong answer. So either math dot square root isn't working, or it can't add up. Which one is it, do you think? Or I know it sounds stupid, but it is Java, so I can't always rely on it to do what I'm expecting it to do. There we go. I've told it which W to use. X, Y, Z and W. Math square root. Math square root. Floats. Yeah, it's a float. The answer to that I damn well know is 4. So 2 times 2 is 4. 8. All of these take precedence over the pluses. That's correct. What have I done wrong? Come on. Why am I getting 2? Why is this coming out to 2? Two, yeah, actually. I should have done that, shouldn't I? Really? Right, so result equals 2. Alright. Result equals 2, correct. What does victim... Get that thing out of my way, thank you. Okay. Stop that one. Alrighty. Y, X, Z. Where's the W? Why is W not here? Doesn't make sense. What's this? Oh, it equals 2. 16. What? What the heck is going on? Oh no. Don't tell me there's a fault in Java. Oh my god. Where's result? Float result equals. There's something very, very strange going on here. Okay. Step over. Result equals 2. Holy crap. So result equals X. This is very, very strange. I've never seen anything like it in my life. There's something wrong here. Big time. Okay. How are we going to do this then? We need a float. Result equals 0.0f. Okay. It doesn't equal 0.0f. It doesn't work like that way. It's Java. Is it? No, it's just me. Ding. Does that work? I'm a bit concerned about this. So I know it's starting at 0. Right. So what we do is result plus equals x times x. I've got to check every single step of it now. Because there's obviously something wrong with something somewhere. Why am I getting errors? Don't know. Plus equals xyz times z. Result plus equals w times w. Okay. Return. Math. Hold on a minute. Yeah, I'll do it here. I want to return result as it is. So result equals float. Because it's a double for a square root. Square root of result. Float will go to a double. Okay. Which means I can now put a breakpoint there. Let's try it. It didn't even go to my breakpoint. What's going on? What the hell just happened there? Okay, put a breakpoint there. Thank you. Where's W? And why are they all equal to 2? What the hell's going on? Alright, they're all equal to 2 at this point. Alright, this. Yes. Understandable. Result 0.0 x2. Okay. Result is 4. y2. I can see something's wrong already. Result is 8. Z is 2. Result is 12. W is 2. Result is 16. And it's going to go through there. And on the next bit, come on. Result is 4, thank you. So it must have been something in the way I wrote it. With the pluses. I'm not going mad, am I? Yeah, I'm going slightly mad. I might not have to do that bit. And there you go, actual 2. So I've got something wrong on the right hand side now. Expected for result equals 2. Right, okay. Let's break it down. Oh. Yeah, that's right. I know what's going wrong now. It wasn't me. I've put square root on both sides, haven't I? That's the reason. There is no square root on this side because all we're testing is the actual code. We're not testing the internals. we're only testing for the result. So it's the result is the victim.length. The square root's already in there, so I was square rooting it again and getting 2. So that's correct. Bad test. There we go. Test complete. Thank you. Found it. Always do in the end. Not really too bothered. But there we are. That's that done. Oh God. Just looked at the next one. Oh dear. Okay, viewers. If you normalize is a quaternion with a length of 1. So we found out how to get our length of 4. How do we get a length of 1? Yeah. So what we can test for is a normalize and then test the length. Now we've got that working. We could cheat that way. We can do the, well, it's not the length that matters, it's the results on the XY, ZW that matter as well. Because they can go all over the place, but if we use 2, 2, 2, 2, oh God. Okay, let's set the test up. Spent enough time on length. I've got to get past conjugate yet. My God. That's a good fun one. So what am I looking for here? Normalized. Yeah, it's just going to return a quaternion. Oh God, why did I choose to do this? Oh dear. Quaternion. So that's what it's going to return. And it's just going to be normalized. That's a nice one. So we grab our quaternion from here, because it's an easy one to change if we need to, and we pop it in here. There we go. There's our lovely quaternion, and it's called a victim. What are we going to do to it? Well, it's going to be a new quaternion. So I'm going to need 2 of these. Oh God. No, we don't. We can just do a victim equals victim. Right, so to test it, we would have victim equals yeah, this is funny. That's the way I set it up. That's to try and get a false. Alright, so that will return from the function and will compile. On this side, we have to do a victim dot normalized. And now we've got to work out the results. I want the results in the same manner that we did these. Up here. So, there's our assertions. So it's 2. I want to make a float. So float result equals gold. What is it? X over length. X is 2 over the length of 4. 2 over 4 is 0.5. These should all be 0.5. Alright, let's see if I get that one right. There we go. So I'm going to set them all to 0.5. Don't need that. Decided. Alrighty, let's try this out, folks. Will it build for starters, or have I made any more mistakes? No, we're building. So let's try running it. And the test should prove false. Yeah, actual 0. That's correct. So that's good. So if we put in the answer, we should be good. So it's float length equals, well, it's just length, isn't it? Yeah. You don't need to put this colon length, although you can. So that. And it is going to be a new quaternion, but it's going to be x over length. So x over length. Ooh, that went a bit fast. So x over length, y over length, comma, z over length, and w over length. I really don't have a good way of explaining this, sorry to say. Really what it is I can't even draw it because it's in 4D. If it was 3D, it'd be the same. So if we have a look at Vec 3, no, not that one. Source, please. If we look at Vec 3 for length, here, you've got that, and then when you normalise it, you take the length, and you take the x over length, y over length. It's exactly the same, except we've got a w component, so it's exactly the same as you would do with a vector 3, to get a vector with a magnitude of 1, so that if we then times that vector by another vector, it will be timesed, it's like timesing by 1. It's the same argument as the identity matrix that we had before, earlier on, where if you multiply or divide by it, it's equal to 1 in magnitude. This is massively useful, and it comes up quite a lot on the physics side, especially in collision detection. So don't worry, it is very, very useful, to say the least. Right. Now that's that out of the way. That looks okay. Any errors? Nope. Go back to here. We've got a red. Run. Finished. Done. Thank God. I'm glad that one worked. Now, conjugate. Oh my God. Let's have a conjugate. Alright. Yeah. What is a conjugate? We haven't had one of these yet. A conjugate only happens to a quaternion. It's where we take all of the unreal numbers, all of the fictional numbers, or whatever you want to call them, and times them by -1. Or reverse them. The W is left alone, because that's a real number. That's my best understanding of it, and I have no other way of explaining it to you, but what it does, if you are rotating one way around an object, then if you use the conjugate, you can then reverse direction and rotate the other way. That's what it's really about. It's reversing your rotation direction in 3D mathematics anyway. So it is very, very useful again, but how does it work? Well, it's very easy. In fact, it's probably the easiest thing you'll ever see. Actually, I'll copy, because it's exactly the same test. But, well, a little different outcome. So what we've got is that. Here we're going to conjugate. Woohoo, what a name. Oh, it sounds like something you do in a nightclub. Let's get jiggy with it and conjugate. Alright. How do we build this? It's a quaternion that we want in return. So it's a public quaternion. And then we want to conjugate. God, I'm not going to get over that one, am I? Did I just do a conjugate? Yes. And we'll just return one of these again. 0.0 f, comma, 0.0 f, comma, 0.0 f, comma, 0.0 f. 1, 2, 3, 4. Good. Alright. How do we do this? So if I put conjugate there, we will have minus 2.0. It's irrelevant what the numbers are actually for this one. Minus 2.0. I mean, really, you should have data sets that you're running through these, to be quite honest with you. You'd have a global data set to run through all of this to make sure everything's correct. You wouldn't do single tests like I'm doing. I'm doing this as mainly as examples of how the system works. It always works in your favour. No matter what happens, you can't go wrong in the program at the end of the day, because both sides. It's like in accounting, you have double entry bookkeeping. Well, this is a similar kind of idea, but you are supposed to really put a lot more effort into breaking your code than I'm doing. I'm not trying to break my code. I'm just trying to get on with the program to show you how it all gets done. But you should really, really, really test properly. Because later on, if something goes wrong, I've got to come back and try and break me tests and say my tests weren't good enough, or I'm going to fail somehow in an unexpected way, and that isn't good. That's rather bad, because I'll be saying, but all my tests are green. Well, obviously I got my tests wrong then. But you've got to watch out for that. Never ever expect your tests to be complete. Never ever think that you have tested every single angle, or there is no way to break your code, because some person out there will do so. And they'll do it in a fantastic fashion, and they will probably hack you. So trust me on that one. Right, so we'll go conjugate. That's what it does. I'm happy with the test. The test should fail. Bah! -2 expected. 0 actual. Perfect. So what's the actual, well, result is obvious. What we do is we take minus x. Oh, I'll just get rid of them. Conjugate, isn't it? Yeah, minus x minus y minus z w. And that's the answer. Build. Looks good. Run. And that's the answer. That's as hard. Oh god, now I've got multiplication. No, yeah. What are we expecting back from this one? Public. A quaternion. So yeah, I know I'm copying and pasting a test. Never ever do that. Obviously, all tests should be individual. Each test should be separate. In fact, those 4 tests should be 4 separate tests. You shouldn't do it all in one, because you want to use different numbers and everything to make sure that everything is correct. And you don't want, obviously, a y value crossing over with an x value, and of course you can't detect it. So you've also got to test negatives sometimes as well. What we're going to call this one? Mul. Okay. Mul. We'll need a right, won't we? Oh god, yeah. A quaternion right. Yeah. So I'm going to need 2 this time, am I? I could multiply it by itself, can't I? Yeah. So that becomes mul. And that becomes victim. And all of these become 4. Looking good. So I expect 4 for each value, because we're multiplying itself by itself. So it's basically, I suppose, yeah, it is basically that way. But is it? I'm not quite sure about that, you know. I don't think it really works that way. Oh, God. How am I going to explain this? Okay. We have 2 different sets of numbers. Okay, if it's unreal, if you add an unreal number, it becomes a negative. And if you add a real number, it's positive. And you've got to multiply these with each of the other variables. So it's 2 times 2 times 2 times 2 type of thing. Oh no, it isn't. It's 2. Oh jeez, how the hell am I doing this? It's 2 times... I'll work out each one individually. Alright. So let's go with W. W is 2 times 2, which is 4, plus 4, plus 4, so that's 12, minus 4, 8. Oh, god damn it. What are you doing? Stop it. Let's try doing the Y number. So it's 4 8, 12, 8. X will work out at 4, 8, 12, 8. It goes back to 8 every time, except for the W. Right. I think the W stays at 4, if I'm right on this one. It's 4 minus 4 is 0, minus 4, minus 4, minus 8. It's a W that goes backwards. That's right. So the... yeah. It reverses direction. Well, no, it doesn't. It reverses the real number. Does the conjugate. And it also multiplies it all out, interestingly. Hope that's right. Let's try it out anyway. Let's try it out. So this is multiplication. So it's float. Oh God. It's multiplication, so I'll use M. I'll do W first. And that's going to equal something. Let me just put it to 0.0f for a minute, whilst I get my act together. We'll have mx oh, I haven't done... Did I do the faults? And I've just done overwritten the conjugate. Oh God, what have I done? Alright. I'm an idiot. I've just proved it. What was it? Oh, that was it. So I know the answers now, but... Sorry, I've just altered the wrong test, haven't I? I've just altered a test rather than write a new one. This is mul here. So it's minus 8. Okay, that is now a mul. And the victim can go inside. There we go. Right, it's in the right one now. Just do that. Do that. And that's going to be 0.0f, comma 0.0f. Do it properly. We need to get the negative, otherwise we can't prove that we can get a positive. And that's that done. Now we're on... Oh, we're nearly at the end as well. Wow, gosh. We might finish everything today. Please, please be wrong. Yeah, that's what I like to see. Lots of red. We'll turn you green, shall we? Alright, now I can get this back and start working on it. This is not the easiest thing in the world to do, unfortunately. My. If I'm just stubbing it out, the equation itself is coming along in a second. Right. MW is the one that's out of the norm, as it were. So, multiplying the W, we have X times the right dot get X. That's right. Then we minus, because it's real. No, sorry, it's unreal that I'm doing next, so it's Y. Y is unreal, so we minus it off. Right. So that will be Y times right dot get Y. You can see how lovely this is. And then we're going to do Z, which is also unreal. So we minus Z off. Z times right dot get Z. As I said, it was lovely. So hopefully that will give me the right answer. X, Y, Z. Is that correct? X, yeah. X is going to be W, Y, Z. So let's get this one started. So W times, it's multiplying, isn't it? So, is that right? I'm not sure if this is right or not. Oh dear. Okay, I'll go with what I'm thinking. Now it starts getting complicated because whatever I do here, it doesn't matter, it's a positive. Yeah. And this one is times Z. Right. Dot get Z on that one. WYZ. Is it? Yeah, it's a minus. So it's Z times. I'm not sure if I'm right with this anyway. We'll put it in. That would be get Y. YZ. Does this look right to you lot? Oh dear. Yeah, I'm just thinking through it. Actually, I think I'm right. X, Y, Z times right. I bet I can break this one. I bet I have got it wrong somewhere. Z changes things, does it? No, that's wrong already. Should start with a W. Always start with a W when you're not using it. When it's not the first. Right, okay. So you always start, and now I need to use the next one, so that's get. Wow, this is blowing my head apart. So, WWXW. Okay. I'm going to have to start this again. So, multiplying a quaternion on the right. Should really look this up, shouldn't I? Float W equals. And I've put X times X when it should be W times W. Then it's minus X times get X. And then it's minus, I think, Z get Z. Oh, got that one a bit right. Well, 1 out of 3 ain't bad. Do the X's. X, and that still stays as a W. Good, that's working. This one goes back to being a W because that's shifted over, that's right. And that gets the X. That's correct, that carries down. W, if I remember rightly, this is now Y? No. Z. WWZ. Why does that sound right? Right. X. W. I think I'm missing something massively here, like another set on the end. Oh dear. Yeah, I am. Alright, so it's W X Y Z in it. W X Y. Yeah, got it now. That's your starter. Once you get the starter, the rest falls into place, they say. I hope it does. Right. And we get Z. Alright, okay. That's Y. Does that make sense now? X is times X. Yeah, that makes sense now. W times W, X times X, Y times Y, Z times Z. That's correct. And they should all be minusing to make minus 8. Correct. Right, yeah. That works. Right, the X line. X, W, and then it's Y and Z. And it's minus C. How many minuses have I got here? Got 1 plus 2 minuses. That's plus, minus. These are not exactly easy things to do in your head. So don't ever try doing 4-dimensional maths in your head. It really doesn't work well for some reason. And we need the Y. Yeah, that's right. That's wrong. That's a Z. That's correct. That's correct. That's correct. It's starting to get correct now. Yeah, that's correct. Good. Right. On the Y, we start with the Y this time. Let's do it properly. Always start with the correct thing. So it's Y times R get W. This is multiplication, isn't it? Yeah. W. Excellent. Now it's a plus, and I know it's a plus. Helvens Tabet. Because now we take the W and we times it by Y. x. This is the y row, isn't it? Right. Y dot get y. Ba bum ba bum bum. Yes, folks, we should do this to a musical tune. No. I'm gonna add again. Can you? I suppose we should really have this. This should have been named conjugate instead of mul. It would have been. It would have fitted the equation that goes with it. Right. So I haven't used z next now, have I? So this one's a z. Is it? Yeah. This one's a z, and we times it by x. Yeah, that's right. At least I'm getting there now. I think it's a minus. And this will be the x. Yeah, that's the x value, and we're timesing that by right. Dot. Which one is left? W, x, y, z. R get z. Lovely. Too easy. It's too easy. Easy game. Z times W. We're gonna add. It's only the first one with all the minuses on, don't worry. These ones are all adds until the last one is a minus, so these are easy. So, put a W in here. We shall multiply that by get y. No, get z. Yeah, that's right. Yeah. Right. Dot get z. That one. Now we can have the next one. So that's W done. Now we can go with the x, because we've got a z after that, haven't we? Nope. We've got x and y left. Yeah. So it's x on this one. We shall multiply this by y. Yeah, we haven't used that. Good. Minus xy. Yeah. Y times. And if you go through them all, you'll notice none of them duplicate. Or shouldn't do anyway. Yx. That's right. Beautiful. Done it. Oh, I think I've done it. I'm running that one. Oh, it's still false. Damn. Because now we have to put in here. Mx. Y. Mz. Mw. Now we can push the button. Woohoo! Push the button, Luke. Oh dear. Oh, you didn't get it. We got a minus. Did I put my minus on the wrong one? Nope. Okay, MW. What's X? Oh god, I've got the X and the W wrong way around, haven't I? That's right. Alright, try it now. I think I put my minus on the wrong one. It should be on the W. Well, hey, got it! How's about that? I think I'll check that offline. I don't trust that one. That was going to get double checked offline. That's horrendous. I've just done 4-dimensional multiplication online and my brains have just gone to porridge. Awesome! Squidgy bits of brain falling out. what's this last one? You want me to multiply it by a vector 3? Are you kidding me? I do set myself some stupid tasks. Oh well. It's got to be done. And remember, you'll only type this once. The next time you'll type it, you will be using copy and paste. I bet you will. So if this is multiply, we can still call it multiply, can't we? We do have overloading. I think we can. As long as it's got a different signature. We should be alright. I set it up for a bad one. And that will do. Right, we've got to work all this one out now. But this is going to be slightly different. Because I'm going to be using a vec3. Copy. And paste. Thankfully, look, there's no more to do. This is the last one. So if I can get this one right, I'm going to just celebrate with a cup of coffee. 2 hours, 35 minutes in, and we are on the last test for our mini maths library. And I'll call it a mini maths library because it isn't finished, but it's close enough to start. We'll need a vec3 for this. Prime equals, what should we have? 2's again? Oops, too many F's. Can I do that? Yeah, probably. There you go. Sorted. And what we're going to do now is we are going to put prime in here, which will activate this multiply by vector 3 on the right. So our victim, all the 2's, will now be multiplied by 3 2's instead of 4. Yeah. What do we expect the results to be? Alright, let's see if I can work this one out. Minus 4. I think it's just half. Hold on a minute, is it half? No, it's all the same, except for the W. Is that correct? Four plus 4 minus 4. Ah. Because now we'll only have 1 plus with 2 sides on it. And 1 minus. Right, okay. So these are 4. So it'll be 2 times 2 is 4. 4 plus 4 is 8. Minus 4 is 4. Okay. It's half. Half the result that you would get for timesing it by a 4-digit. Well, I suppose that makes sense that we're using 2's and it's gone by half. Yeah. That's it's like a scaling effect, I suppose. I'm not sure what you could call that, but that's what I'm hoping is the answers. How much is it if this is true? That's another problem. I don't know. Wait a minute. No. How do you do it on this one? Shift, Alt, drag, no. Drag, no. How do you select a square? Control Shift, drag. No, never mind. I'll copy the lot in. Right. So I don't think we need all of that lot there. So W, X, Y, Z is what we're looking at. W, X, Y, Z. Yeah. And we're going to get that as a quaternion back. So we can change that straight over. If it'll let me. Excellent. W, W, W. If we can get the first one right, we're well on our way. But there's only going to be one minus, so it's something comes off in between, and I've got a feeling it's that one there. So I'll take the X over. We'll get rid of all the red, and then I'll start working it out on the top line. So it's shorter than the other one. Not by much. Right. X, get X, correct. And then it's Y, get Y. Yeah. Then it'll be Z, get Z. Yeah, I'm with that one. MX will be... We don't have a W. Yes, we do. Darn it. W, get X. And then it's plus Y, get Z. Yeah. Z, get Y. Yeah, okay. Y is W. Get Y, yeah. Z, get X. Yeah. Z, right. X, Z. Yeah. Oh, God. Z. W. Yeah. X. Yeah. Y. Yeah. Push it there. Done it. And that's it. We did it. Sorry, I didn't get the negative, did I? Damn it. Oh well. Never mind. I'm not going to do it again. No ecking way. Right. And that concludes my maths bits and pieces for now. That does give us, rather nicely, a good basis to do a 3D game engine. We now have maths, we have time. Map 4 main component is our thing. Oh, that's still doing that. How do I get it back onto my main component, please? Stop running that. Oh well. See if we've got any red markers left lying around. Process finished with exit code 0. Okay, thank you. Don't want tests anymore. You stop it. Alright, so we now have 60 frames per second. Come on, stop at your 57s. And Cat coughing. We have 60 frames per second. We have a window. We have a maths library that has been summarily tested, not totally tested, but good enough because, to be quite honest with you, I knew all the answers, but because I've done it before. Does the escape key work on this? Yes, we've got the escape key working. Good. Good. So we've really got most of this done, which means we can do the rendering next. We can actually put some on screen now. We should have enough there. I want to keep that open because I do want to carry on testing. I have no ideas how I'm going to do it because I haven't tested this class, and this worries me. None of this code has tests. And I'm not sure what that's doing. Did I put a window up or not? Welcome to the Java 3D game engine. No, I didn't. Can OpenGL be used in here? No, it can't. How interesting. So we haven't really written any OpenGL at all. Oh my god. That's going to cause us problems because there's an extra step on Java. Okay, where are we going to put it? Right, I've got to think about this for next week because I really want to start heading towards a renderer. We don't have one at all, so a rendering class, as it were. I mean, this window is totally platform specific, is it? No, it's not. This is not platform specific. This is generic. Right, so this will work on any machine, what we've got so far. So if you watch each Saturdays from the beginning, you will get to here. You will find it all on Amberskies, of course. What are we on? Learning to program. And it'll be the next one over about. Naval. How interesting. Why isn't it on here? Oh, right, that's the top layer. Alright, that's bits and pieces. Where's it disappeared to? Got that many playlists these days. I'm not sure where half of them are created playlists. Okay. This is a Saturday one, isn't it? It's learning to program. What's happened to it? Where's it disappeared to? There it is. Right, I found it now. Phew. Oh, cancel. At least now it's that one there. So this will be the 5th video that's going to go up on Amberskies over on YouTube. So you can go back and bring yourself up to date with everything if you wish. There's quite a few hours of videos there. Whoa, gosh, we're getting long on this one already, and we've only just got past a basic. Well, no, we haven't only just got past. We've actually created a basic maths library. Instead of using a predefined one, we have control over this one, and it will work in the way that we want it to work by the time I finish with it, and thrown it around a bit and punched it one, probably, and screamed at it. But that's what it's all about. This is programming from scratch. I'm not here to use a load of libraries. It's just that with LWJGL, the lightweight Java game library, came, unfortunately, this Windows stuff, which was all in GLFW. So, yeah, the Windows wasn't as easy as it could be, but this is a good system. This is brilliant, and I've got the key presses right. So we've got these key downs and his mouse button down, all sorted out and sorted, and there aren't any callbacks. If I was doing C++, I probably would have used callbacks. As it's Java, I know you can, but I'm not gonna. I'm not that bothered. It'll still work if you don't use callbacks. There's two ways of doing it. That's GLFW for you, though. Main component is quite interesting. It's got time all over the place and doing stupid things. If you can work it out, good luck. The guy who actually did this, I have a lot of respect for, but I do think he overthinks things sometimes. This would have been easy just to call the time and have this do all of that gobbledygook rather than have it all in the main. But I might clean it up after we've finished. I don't want to break his code, as it were. I have too much respect for him. I'm not sure I want all this time stuff, though. It's very nice. It was just an example of overthinking and how if you sit down and you think about a problem for too long, you will come out with something like this. It's obvious that's what's happened. But hey-ho. It's in here at the moment. I'm not going to refactor yet. We're not at the stage for refactoring anything yet. We haven't got enough to do anything with. So that will come later. We are nearing the 3-hour mark. So my cheers, my hurrahs. We have made it into rendering next Saturday. Back here at 2 o'clock in the afternoon. Tomorrow I will be sailing. I need a break. I'm going to go sailing. As you can see by my Windows background, I do sailing online. And that's the boat I will be sailing probably. In fact, it is the boat I am sailing tomorrow, I think. So that will be naval action, 2 o'clock in the afternoon. It'll be here on Twitch. If you want to join us for that, you can do. It's just a bit of relaxation. I might even shoot a few of these guns off at something like seagulls or the British, if I can find them. I am playing a pirate, so, well, why not? I'm called Blades, after all. That's my nickname. I've got to be a pirate, haven't I? You can join us in the game if you want. I don't know if you have to pay for it or not nowadays, but it's on Steam. It's called Naval Action. Have fun with it. In the meantime, what are we doing next week? Oh, yes. Next week, I am probably doing an ECS, Entity Components System, on the main C++ stuff in the game club. That will be Monday, Wednesday, Friday, and on Thursday, you get a behind-the-scenes tour of what I do. In Blades World. Everything is at 2 o'clock in the afternoon. That's when I start because I'm not awake before then. I'm not a morning person. So, in the meantime, let's play the outro. Any questions? You got till the music stops.